Hello everyone, my name is Nidhi Singh. I am assistant professor in Gyan Vihar School of Pharmacy, that is a part of the Suresh Gyan Vihar University, Jaipur. So today we are going to discuss the topic that is the classification and nomenclature. This is your first unit and comes in a pharmaceutical organic chemistry first, in second year or second semester. So let's start the topic. So let's check the learning objective. So the learning objective of this topic is to learn about the nomenclature of complex organic compounds, and also here the student outcome is that here we are going to here the student is going to know about how to give meaning to the complex organic compounds. Let's start the topic. The Iupac nomenclature of complex compounds. So according to the Iupac system of nomenclature, any given organic compound can be represented by one and only one molecular structure, and in general, the Iupac system of naming an organic compound consists of three parts. Means here, if we are naming the organic compounds, then according to the Iupac system, it consists of your three parts, that is your prefixes, root word, and the suffixes. So in this, your Iupac system, the Iupac system of nomenclature of any organic compound, it can be represented by one or more molecular structure, and the Iupac structure of naming an organic compound consisting of the three parts, that is your prefixes, root word, suffixes, and the root words depend upon the number of carbon atoms. The root words depend upon the number of carbon atoms that are present in a suitable chain, that is called the parent chain, and containing the functional group and as many of carbon multiple bonds as possible. And these root words, which is the part of this Iupac system of naming an organic compound, if the root word is depend upon the number of carbon atoms, the number of carbon atoms that is present in a continuous chain. So that continuous chain is called the parent chain, and if that parent chain consists of, it contains the functional group and many of carbon multiple bonds as possible. Means here the carbon chain, that is the parent root chain or the parent chain, that is consisting the carbon as well as the single bond, as well as in that chain there must be a function groups also present and the multiple bonds also present. The appropriate suffixes is then added. To the root word to denote the saturated or unsaturated character of the parent chain and also the functional group that are present therein. So these suffixes is then added. These suffixes then added to the root word to denote the saturated or unsaturated character of the parent chain and also the functional group that are present and denotes these appropriate suffixes is then added to the root words that are denoting the saturated and unsaturated character of the parent chain. Means here the parent chain, which is consisting of the bonds, means they are consisting of the single bond as well as the multiple bonds. So they are donating, that root word is denoting that this is a saturated compound or the unsaturated. Means saturated means if it is consisting of the single bond, then it is your alkane, and if it is consisting of the double bond, then it is your alkene. So here it is showing, or triple bond, then it is your unsaturated. So here it is showing the character of the parent chain and also the functional group present in it. So the functional group that are present in the functional group. So finally prefixes is put to indicate the nature and position of the side chain or subsequents. So here the prefixes put to indicate the nature and position of the side chain or subsequents. The basic rules for Iupac system are, the basic rules for the Iupac systems are longest chain rule. Means here the rule that is the basic rule, the first rule for this or the basic rule for this Iupac system is the longest chain rule. Means the longest chain rule. It means that the longest possible continuous chain of carbon atom containing the functional group and carbon-carbon multiple bond is first selected and the root word corresponding to it noted. Means longest chain rule means here that we have to first find out that which is the continuous longest chain of carbon atom is present, what type of functional group it is having, what type of multiple bonds it is having. So first we have to select the function group as well as the carbon-carbon multiple bonds are selected. So this and the root word corresponding to it is noted. Like this example is shown here that the CH3, CH2, 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 CH, CH3, CH3. So we have to select that which is the longest chain. Either this one, means this one, or the straight one. So first we have to check that 1, 2, 3, 4, 5, 6. So this straight chain is having the 6 carbon atom, and this 1, 2, 3, 4, 5, 6. This is also having the 6 carbon atom. So here we can take any long chain. We can give name to the any long chain that is 1, 2, 3, 4, 5, because in the both chain the number of carbon atom are the same. So here it is having 6, so its name is your hex, and it is having the single bond, so it is your ane, means it is your alkane, so it is your hexane. Next is your CH3, CH2, 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 CH3. So this is the simple, means here it is showing that this is the simple. You can count and write the name of the compound. So next is your root word. So the root word for the number of carbons are here. For the 1 carbon atom, the root word is your meth. For the 2 carbon atom, the root word is your eth. For the 3 carbon atom, the root word is your prop. For the 4 carbon atom, the root word is your but. For the 5 carbon atom, the root word is your pen. For the 6 carbon atom, the root word is your hex. And for the 7 carbon atom, the root word is your haft. And for the 8 carbon atom, the root word is your oct. 9, non, 10, dec. And the primary suffix. So the primary suffix is to be added to the root word to indicate saturation and unsaturation. Selecting the chain, and the generic root word for any carbon chain is alk. So the generic means here the root word for any carbon chain, means any carbon chain, the root word will be your alk, and this alk comes from the alkane. So the chain type means if it is a saturated means if it is having a single bond, then the suffix will be your ane, and if we are mixing the generic name, then alk plus your ane, so it becomes alkane. Next is your unsaturated with 1 double bond. It means it is having the 1 double bond. Then it is your ene. Ene means here that it is consisting of the double bond. So here its name is ene. So its name is alkene. Next is your unsaturated with 1 triple bond. Means if it is having the 1 triple bond in the chain, then it will be represented by the suffix "-ine". So its name will be alk plus "-ine", that is your alkyne. Next is your alkane. Alkane, it means here 1 minus 1 H, means 1 H is deleted, means 1 H is removed from the alkene, that the suffix will become the "-ile". So its generic name is alkyl. So this is the primary suffix. So the primary suffix is to be added to the root word to indicate the saturation, means it is a saturated or it is unsaturated for selecting the chain. So the generic root word for any carbon chain is your alk. From alkane, the chain type is your saturated, and the suffix is your ane, and the chain type is saturated, ane, and the generic name is your alkane, and the unsaturated with 1 double bond is your ene, so its name is alkene. So the unsaturated with 1 triple bond, its name is your ine, so its name is your alkyne. Next is your alkyl, means alkane. From the alkane, 1 H is replaced. So the one, if one H is replaced, then if the suffix become your "-il", so its generic name become your alkyl. So it become your alkyl. So the name will become, the generic name will become your alkyl. So next is your secondary suffix. So the secondary suffix will be, your secondary suffix is added to indicate the number of functional group if present in the compound. So if the secondary suffix is present in the chain, then it will indicate the nature of the functional group. So first, primary suffix is your saturation and the unsaturation. Secondary suffix is your tell about the nature of the functional group if it is present in the compound. So some functional groups are given below. So the functional group for the OH, it is your secondary suffix is your ol, and for the aldehyde, it is having the secondary suffix is your al, al. So for the ketone, it is having ol. For the carboxylic acid, it is oic acid. From the functional group ester, COOR, it is having OH. For the amide, it is having CONH2, so it is the secondary suffix will be your amide. So acid chloride, COCl, for that it is your oil chloride. So in the terminal, so the terminal E of the primary suffix is replaced by the secondary suffix. So the terminal E, so the terminal E of the primary suffix means here the E is replaced by the, in the primary suffix by the secondary suffix. So the formula is your HCHO and the number of carbon are 1. So here in the HCHO, the number of carbon atom present in this HCHO is your 1. So here the number of carbon is 1. So its root word is your meth. So the root word is your meth. So here the primary suffix is your ane. So primary suffix will be ane because there is no double bond present. The double bond is present between the carbon and the oxygen. So here, so its primary suffix is your ane and un. So E is from this ane, this E is replaced by the al, because there is a functional group that is the aldehyde is present, and for the aldehyde functional group we use the secondary suffix that is your al. So the secondary suffix will be your al. So the Iupac name will become your methanol. So its name is methanol. So a root word is your meth. Primary suffix is your an, and secondary suffix is your al. So methanol. Next is your CH3CH2OH. So in your CH3CH2OH, the number of carbon is your 2 carbon. So in the CH3CH2OH, the number of carbon, you can see here there are the 2 carbon atoms are present, and in this 2 carbon atom, the number of carbons are the 2 carbon atom, and the root word is your eth. So the root word is your eth, means ethane. So here the 2 carbon atoms. So here the root word is your eth. So primary suffix is your ane because E is replaced by the ol for this secondary, because here OH function group is attached. So for the OH function group, you can see here for the OH function group, the secondary suffix ol is present. So here it is your CH3CH2OH, and the root word is your eth, and the primary suffix is your an, and the secondary suffix is your ol. So its name is ethanol. Next is your CH3COOH. So CH3COOH, this is your carboxylic acid. So in this also the number of carbon atoms that are present is your 2, and the root word is your eth. So root word is your eth. So in the primary suffix is your n. So primary suffix is your n, and the secondary suffix is your oic acid. Secondary suffix is your oic acid, because for the carboxylic acid you can see here that the secondary suffix is your oic acid. So here the secondary suffix is your oic acid. So its name, according to Iupac name, its name is your ethanoic acid. So here its name is your ethanoic acid. So CH3COOH, the number of carbon atom present is your 2, and the root word is your eth, and the primary suffix is your N, and secondary suffix is your oic acid. So its name is your ethanoic acid. Next is your CH3, CH2, CH3. So here the number of carbon atoms are present. That is your 3, and here you can see 3 carbon atoms are present. So we will use the root word prop. So the root word used here is prop, and the primary suffix is your A-N-E, because here no other secondary suffix is attached to this chain. That is why we are not using any secondary suffix. So its name, Iupac name will be simple, that is your propane. So Iupac name is your propane. Next is your CH3, CH double bond CH2. So here you can see the 3 carbon atoms are present. So for the 3 carbon atoms, so here for the 3 carbon atoms, we will use prop. But you can see here that there is a primary suffix. The primary suffix here tells you about the difference, that there is a saturation or the unsaturation. So here there is a unsaturation. So here the double bond, means here the double bond is present between the first and the second carbon atom. So here the we will use here the primary suffix, that is your ene, because one unsaturated double bond is present. So its name is your propene. Next is your CH3, C triple bond CH. So in this case, there is your 3 carbon atoms are present. So in the 3 carbon atom, you can see here on between the first and the second carbon atom, there is a triple bond is present. And for the triple bond, because here one unsaturated triple bond is present, so here the suffix is your ine. So its name is propine, and the example is your propine. Next is your CH3, COCH2, CH3. So here CH3, COCH2, CH3. Here you will see that there are 4 carbon atoms are present, and between the 4 carbon atoms, the primary suffix is the root word is your but, and the primary suffix is your in, and the secondary suffix is your ketone, and for the ketone we use the that name is your own. So here the E is replaced by the own. So E is replaced by the own. So its name is your butanone. So its name is your butanone. So here its name is your butanone. So next is your prefixes rule. So in the prefixes rules, the prefixes are to be added to the root word to represent the side chains and the substituent. So prefixes are to be added to the root words to represent the side chains and the substituent. Means that the prefixes that are added in the starting of the root word, they are representing the side chains. Means if any other side chain is present in the longest carbon chain, or any substituent is attached in any substituent is attached to any of this chain, then this is represented by the prefix. Next is your alphabetical arrangement of prefixes rule. So the alphabetical or arrangement of this prefixes rule, if there are more than one side chain or the substituent, they should be prefixes in the alphabetical order. When 2 or more identical side chain substituents are present, their location and numbers are represented by prefixing die, etc. before the subsequent side chain. So alphabetical arrangement of prefixes rule. So in this, if there are more than one side chains are present, then they are side chain or the substituents are attached, and they are prefixes in the alphabetical order. So here in the example, you can see the CH3, CH, CH, CH2, CH2, CH3, and on the second and the third, there are 2 substituents are attached, or you can say the side chains are attached. So here, firstly, you have to identify the longest chain. So by writing the number, so here we have written the number, the numbers are written on the carbon atom. So here the 6-membered ring it is, and the root word is your hex. And as you can see here, it is your saturated compound. So here the primary suffix will be your ane. So here no other secondary suffix is not attached. So here no other secondary suffix is present. So here its root name, parent name is your hexane. Next, on the second and the third carbon atom, there is a methyl group as well as a ethyl group is attached to the second and the third group. So, on the according to the alphabetical order, E comes first, then the M. So here we are naming it 3-ethyl 2-methyl hexane. So its name is 3-ethyl 2-methyl hexane. Next is your CH3CH. CH3. So in this, on the second and the third carbon atom, the methyl groups are attached. So its name is your 2,3-dimethylbutane. So here, as the line is written, when two or more identical side chain substituent are present, their location and numbers are represented by prefixing di, tri, tetra, etc. before the substituent and the side chain. So here we are here you can see the two identical side chain, means here the CH3 and the CH3 both have the same alkyl group. So it's so here we are prefixing it with the di. So here on the second and the third, the dimethylbutane. So because the root word is your but, because 4 carbon atoms are there, so its name is but. So here we have used the root word but, and ane because here primary suffix is ane because here all the bonds are between the carbons are the single bond. So its name is butane. So on the second and the third carbon atom, there are two alkyl or ethyl groups are present, and both are the same. That is why we are naming it 2,3-dimethylbutane. Next is your lowest sum rule. So here the sum of the numbers used to indicate the position of the substituent should be minimum. The parent carbon chain is to be numbered from one end. The position of the substituent and function group is indicated by the number of carbon atoms to which they are attached. So here you can see the lowest sum rule. The sum of the number used to indicate the position, the sum of the numbers used to indicate the position of the substituent that should be minimum, and the parent carbon chain is to be numbered from one end in the position of substituent and function groups is indicated by the number of carbon atoms to which they are attached. So here you can see that if this example is given, and in the example you can see here that CH3CC or on the third carbon atom the X is given, and here also this is the same. So in the second this is your incorrect, and in the first this is your correct, because you can see if we are numbering it from the right side of the carbon, then it is getting the position 4th, and the X is attached to the 4th carbon atom. And if we are numbering it from the left side, then it is showing at the place at the number 3. So 3 is the lowest number, lowest sum. So here that is why this first one is correct. So as to this lowest sum rule, the sum of the number is used to indicate. So this is used to indicate the position of the substituent, and the position of the substituent should be the lowest or the minimum. So the parent carbon chain is to be numbered from one to the end. Means here the parent carbon chain should be numbered from one end to the another end, one end to the last end, and the position of the substituents and the function groups is indicated. It is indicated by the number of carbon atoms to which they are attached. So in the first it is your correct, and the second one it is incorrect. So the second is your CH3 CH2 CH3 CH2 CH3 CH3, and in this you can if we are numbering it from the left side, then this if we are numbering it from the left side, then this is having the CH3 CH2 CH2 CH3. So here the position of the substituent attached comes on the third and the fifth position. So third and the fifth, uh, these are the identical alkyl, means all are the same methyl groups are attached on the third and the fifth position. So its name is 335 trimethyl hexane, because this is a hexane molecule. Okay, so in the second one, if we are numbering it from the right side, if we are numbering it from the right side, then 1, 2, 3, 4, 5, 6. So here on the second and the fourth, uh, it is getting the second and the fourth carbon atom. So it is having the correct name. So this is the correct name. So this is the correct name, because you can see here, this is the lowest sum rule. As in case of second, the sum of number of substituent is 2 plus 4 plus 4 equals to 10, which is less than 1, where the number of the substituent is 3 plus 3 plus 5 equals to 11. So we have to take the lowest sum rule to name our compound. So here, this is your correct and this is your incorrect. So when two or more groups are located in equivalent position in the carbon chain, the lowest number is assigned to that group which is written first in the name of the compound in the alphabetical order. So here you can see here the two groups are attached here. This is your ethyl group and this is your methyl group. So here we are numbering it from this side because this is nearer to this nearer to the this carbon. Okay, so and because it is nearest to this, because it is attached to the second position, and it is attached, if we are numbering it from this side, it is attached to the third position. That is why we are numbering it from the second position. Okay, and if we are writing it name, then we have to write the ethyl first compared to the methyl, because ethyl is having the alphabetical order, because in the alphabetical order E comes first as compared to the as compared to the methyl. So here the E name, while writing the name, its name is 2-ethyl 6-methyl octane. Oct is the root name, ame is the primary suffix, and the prefixes, first will come the ethyl because E comes first in the alphabetical order. After that, the M comes, so its name is 2-methyl 6 2-ethyl 6-methyl octane. Okay, next is your, in case the substituents on the parent chain is complex containing more than 4 carbon atom, it is named as substituent alkyl group whose carbon chain is numbered from the carbon atom attached to the main chain. So here you will see that it is your firstly we have to check which is the longest chain. So here we have numbered it 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is your no name, known because it is having the 9 carbon atom, ame because all are having the single bond, all carbon atoms are attached by the single bond, so its name is no name. So here you will check that on the 5th position this group is attached, this whole group is attached. So here also we are doing the numbering. So here it is your propyl. Okay, so it is having the 3 carbon atoms, that is why we are naming it propyl. So on the first, in this propyl, so on the first position, one methyl group is present. On the second position, the methyl group is present. So on the main fifth group, on the main fifth group, we will use this bracket, or in the bracket, we will write this substituent. It means here 1 and the second dimethyl propyl nonane is present here. So its name is your 5-1,2 dimethyl propyl nonane. So its name is 5-1,2 dimethyl propyl nonane. Next is the position of double bond. Position of the double bond or triple bond in alkene or alkyne is indicated by the suffixing the number of the carbon preceding such a bond on the carbon chain being numbered from the end which assign the lower positional number to the double or the triple bond. Means here that if any substituent or any alkyl group is attached, as well as there is a double or the triple bond is present in the chain, then what we have to do, we have to use the double and the triple bond as a suffix, and the a substituent that is attached to this that chain is attached like your prefixes. We will use that as a prefixing. So here the position of the double bond, the position of the double or the triple bond in alkene or alkyne is indicated. So here it is indicated by prefixing the number of the carbon preceding such a bond, the carbon chain being numbered from the end, which assign the lower positional number to the double bond. So the lower positional number to the double or the triple bond. So here in the first example, it is shown that the CH3, CH double bond, CH, CH2, CH2. So on this, the second position, the carbon atom, second between this carbon, second and third carbon, the double bond is present. So here the double bonds are present between the carbon second and the carbon third. So here it is written, the name is pentene. So pent is the root name and ene is the primary suffix. So here the double bond is present. If we are numbering it from the right side, then it will come to the third position. And if we are numbering it from the left side, then it comes on the second position. So the lowest position is from the left side. So we are numbering it from the left side. So its name is 2 pentene. So pent because it is having the 5 carbon atom, and 5 carbon atom double bond is present there. So it is your ene. So its name is pentene, 2-pentene. Next is your this CH3, CH2, CH2, C, CH2. So in this 1, 2, 3, 4, 5. So on the second position, the ethyl group is attached. So the double bond comes nearer to this right position, from this right position. So its name is your 2-ethyl 2-pentene. Sorry, 2-ethyl 1-pentene, because on the first position the pentene group is attached. So there is a little correction here. So 2-ethyl, because on the second position the ethyl group is present, and on the between this first and the second position the double bond is present. So its name is 2-ethyl 1-pentene. Next is your CH3, CH, CH3, CH, CH3, C triple bond C, CH3. So in this, the longest chain is your 6 carbon atom, that is a hex, and there is a presence of the triple bond. So we are not numbering it from the left side because the alkyl group is nearer to this left side, but we are numbering it from the left side because the triple bond is nearer to this right side. So that is why 1, 2, 3, 4, 5, 6, and on the fourth and the fifth position the dimethyl group is attached. So its name is 4,5-dimethyl 2-hexyne. So its name is 4,5-dimethyl 2-hexyne. Next is your next, again, in the case of the substituent on the parent chain, it's complex, means it is containing more than 4 carbon atoms. It is named as substituted alkyl groups whose carbon chain is numbered from the carbon-carbon atom attached to the main chain, that is your 5,1,2-dimethyl propyl nomine, and the position of the double bond, or triple bond. The position of the double bond or triple bond in alkene or alkyne is indicated by prefixing the number of carbon preceding such a bond, the carbon chain being numbered from the end, which assigns lower positional number to the atom or triple bond. So here the example is given, that is CH3, CH double bond CH, CH2, CH3. So its name is your 2-pentene. And in the second CH3, CH, CH2, CH3, CH3, its name is 2-ethyl 1-pentene. Next is your CH3, CH, CH3, CH, CH3, C triple bond C, CH3, its name is 4,5-dimethyl 2-hexene. Next is the lowest number of functional group. So here, when a functional group is present in a compound, the lowest number must be given to the functional group even if it violates the lowest sum rule. So its name is CH3, CCH3, CH3, CHOH, CH3. So here the functional group is present, means here the substituent is present on this. So we are so if we are numbering it from the right side, so the substituent, the functional group will come to the functional group will get the more or higher position, means the number more higher number. So this is incorrect numbering. So here in the second, you can see we are numbering it from the right side. So if we are numbering it from the right side, so here you can see that 1, 2, 3, 4. So on the second position, hydroxy group is present. So its name is 2-hydroxy, 3,3 dimethyl butane. So this is the correct system. And in this 3-hydroxy 2,2-dimethyl-butane, it is an incorrect system of numbering and naming, and this is the right, because on the second position the hydroxy is present. So its name is 2-hydroxy 3,3-dimethyl-butane. Or we can write like this, 3,3-dimethyl, 3,3-dimethyl butanol. 3,3-dimethyl butanol. So the parent chain in a halogen substituted alcohol first would be numbered so as to give the lowest number to the functional group OH. So here it is correct and this is the incorrect. Means this is your one compound and this is your another compound, and here we are giving this more priority because it is having the higher priority than this halogen. So this system is correct and this is your wrong, because here we are giving the this halogen the more priority as compared to this hydroxy group. Next is your the numbering of the parent chain in the alcohol second can be done in two ways. So here you can see the numbering of the, in case B the functional group OH, in case B the functional group OH getting the lower number 3, okay, but in case A it is getting the higher number 4. So however the sum number used to indicate the position of the functional group and the side chain. So in 4 you can see it is 4 plus 4 plus 3 equals to 11. So here 4 plus 4 plus 3 equals to 11, and in case 1 it is your 3 plus 3 equals to 4, that is your 10. Okay, so here the in according with this rule, the former system of numbering is perfect. So here this system is your perfect. So numbering the carbon in terminal and non-terminal function group. So the carbon in chain terminating functional group such as COOH, CHO, CONH2. So this is your carboxylic group, aldehyde, amides, nitriles, etc. must be always be given number 1. So they should be given preference to 1, and the carbon of non-terminal group means here that ketone, they should not be assigned as number 1. For example, here given that if COH group is attached, then this COH group is having the carbon atom. So here it should be given the number 1 position. So this COH group is having the number 1 number. So its name is your 3, because on the third position the ethyl group is present. So its name is 6. We can't start the numbering from this carbon atom, from the CH2. This carboxyl group is also having the carbon present in it. That is why we are starting our numbering from this carbon atom. So it is having this 3 ethyl on this 3 ethyl hexanoic acid. And in the second, this is your we can start the numbering from the CHO group, So here the numbering is starting from this 1, 2, 3, 4. So starting 1, 2, 3, 4. So here on the second position, the ethyl group is attached, and on the third position, this methyl group is attached. So here's 2 ethyl, 3 methyl butanol. Its name is butanol, not butanol. Butanol is the name for the alcohol. Okay, so there little correction is also need to be here. Next is your this is your CH3, CH2, CO, CH2, CH, CH3. So this is a non-terminal. group. This is a non-terminal. We can't start the numbering from this carbon, but we can start the numbering from this carbon atom. So here the numbering will start from this carbon atom, this CH3 group. So its name is 5-methyl hexanon 3. So its name is 5-methyl hexanon 3. Again, in case in this structure, you can see this is your A and this is your B. In this case, the B is having the lower position. This is having the lower position, that is your third. And in this, it is having the this hydroxy is having the position 4. So if we are taking the sum number, then it is having the 11 and this is having the 4. This is having the 4, 10 and this is having the 11. So according to this sum rule, there is the former system is correct. So numbering the carbon in terminal or non-terminal functional group, the carbon in chain. The carbon in chain terminating functional groups like your COOH, CH, CONH, 2CN. These are the terminal functional groups. So here we can start the numbering from this carbon atoms. So here in this example, you can see 3-ethyl hexanoic acid. So in this, we are starting the numbering from this carboxylic acid, not from this carbon atom. So here this is having the name 3-ethyl hexanoic acid, and this also same, but this is a non-terminal example. So it is we are not starting the numbering from this carbon atom. We are starting the numbering from this carbon atom. So its name is 5-methyl hexanoic hexanon 3. So its name is your hexanon 3. So it is your this. Next is your numbering the carbon. So here the carbon multiple bond. While numbering the while numbering the parent chain, while numbering the parent chain containing carbon-carbon multiple bond, the lower number of 2 carbon involved in the multiple bond is used to indicate the position of the multiple bond, and the number 2, for example, is used to indicate the position of the double bond in alkene. So it is having the name 4-methylhexene 2. So prefixes for alicyclic compound. The word cyclo is prefixed to the root word as the compound being named as alicyclic compound. And when alicyclic compound contains side chain or any substituent, they appear as secondary prefixes before the word cyclo. So naming polyfunctional compounds. So when a compound contains 2 or more different functional groups, so one of the functional group is chosen as a principal functional group, and the remaining functional groups are indicated as substituent in the Iupac name. So the following guidelines are to be determine the position of the primary and the secondary functional group by giving Iupac name to the polyfunctional organic compound. So here to the polyfunctional group compound, when a compound contains 2 or more different functional groups, so one of the functional group is chosen as the principal functional group, and the remaining functional group is chosen as the secondary functional group. So the following guidelines should be determined for giving the choices to the primary and the secondary functional group by writing the Iupac name to the polyfunctional organic compound. So when 2 or more than 2 functional groups are present in a compound, the principal functional group generally gets the following order of preferences. That is, your acid is having the main carboxylic acid, then acid derivatives, including the nitrile, excluding the nitriles, aldehydes, then nitriles, ketones, alcohols, amines, ether, alkenes, and alkynes. So while selecting the parent chain in a polyfunctional compound, it should be ensured that it includes the maximum number of functional group present, including the principal functional group. While numbering the parent chain in such case, the following is the decreasing order of preferences for giving the lowest number. So the principal functional group, then the double, then the triple, and then the substituent. And if branching alkyl group contains multiple bonds and functional groups, the side chain is numbered separately so that the carbon atom in the side chain, which is itself bonded to the parent chain, is designated as 1. So the application of this rule may be demonstrated by the following examples. So these are the examples I given. So this is the 1-bromo-2-methylbutane and bond line. So here the bond line notification of organic compound means here the bond line are shown here. Next is for the polycyclic compounds. So here you can see here that many of times hydrocarbon of the Their derivatives contain two or more rings, and the carbon atoms combined to both the rings are called bridgeheads atoms, and the each bonds or chain of a carbon atom connecting both the bridgehead is called a bridge. And the bridge may contain 0, 1, 2, etc. In the carbon atom, that is illustrated by the following example. So this is the bridgehead atom. So a bicyclic compound is named by attaching the prefixes bicyclo to the hydrocarbon having the same total number of carbon atom as in two rings, and the number of carbon atom in each of these three bridges connecting the two bridge head carbon atom is indicated by the Arabic numeral, that is the 0, 1, 2, 3. And these Arabic numerals are arranged in descending order, separated from one another by full stops, and then enclosed in square brackets. So the complete name of the hydrocarbon is then obtained by placing these brackets between the prefixes bicyclo and the name of the alkene. For example, here given the bicyclo 210 pentane, because this is having the 5 carbon atom. Next is your butane. So its name is bicyclo 110 butane. Next is the heptane, it's 221. So these are the examples of the bicyclo. If a substituent is present, the bicyclic ring is numbered with the one of the bridgehead atoms and the numbered as 1. And these are the following examples shown here, showing the bridgeheads. Next is an example of the spiro compound. So here the spiro compounds are given, and we have to write the name spiro in it. Now the question. So which of the following is an alkane? That is your cyclohexane. So chemical formula, looking at the chemical formula of this compound, which is the alkane, that is the CCH8, and the name of this compound is your secondary amine, and this compound is your 2-aminobutanoic acid, and this compound is your ethyl pentanoic acid, and this is having the name methyl pentanoid, and this is the references from where you can study this topic. And thank you so much for today's lecture.